You made it. It's time for the Unit 4 practice test. You know the drill. We're going to start with the first half today, and the second half in the next recording. So we're going to go through problems 1 through 6 because there are 12 questions on the practice test because there are also 12 questions on the Part 1 test. There is no Part 2 test this unit, so some good news there. But there is only one attempt for the Part 1 test, so make sure you study so you're ready. Let's go ahead and work on number 1. As always, I'll pause to give you a chance to pause this recording and practice before solving and explaining. Now let's get into it. The question is asking you to convert from a recursive rule to an explicit rule. And they give you this information right here. And they're telling you this is the recursive rule. So what you need to do is look at this information and ask yourself, is this the recursive rule for an arithmetic or a geometric sequence? Well, if you look at your notes, you should see that this is dealing with an arithmetic sequence. So we'll be looking at our explicit and recursive rules for arithmetic sequences. Okay? So let's do it. We need to mix and match, essentially. So what we're doing is we're looking at the information given right here, and we're taking it apart. We're saying, okay, what is this plus 7? Well, if you look here, that's D. So where is D in our explicit rule? It's at the end. So there we go, 7 at the end. Let's do the same thing for a sub 1. They very clearly tell you what a sub 1 is. So once again, you look in your explicit rule, a sub 1 is in the front, right after the equal sign. So we put it right there, and all of the work is done as far as substitution goes. Now we need to simplify. So we distribute. So we ultimately multiply that out. And then we combine like terms to get our simplified explicit rule. We have now successfully converted this from recursive to explicit. Now, let's try to do exactly the opposite. Convert from explicit to recursive. Once again, it's going to be up to you to look at this rule and determine arithmetic or geometric. And this should take you just an extra moment of thinking when you look at your rules. Give it a try. Okay. Here we go. This is an arithmetic sequence. How do you know? Well, first and foremost, they told you this is the explicit rule right here. And that doesn't quite look like the explicit rule for an arithmetic sequence, does it? There should be a plus sign. There's no plus sign. There should be parentheses. There's no parentheses. So how do we know it's the explicit rule for an arithmetic sequence? Well, it's because if you look at the explicit rule for a geometric sequence, let's find that. Here it is. It looks quite different. Specifically, you have n minus 1 in the exponent place. And notice for the problem we're working on, there are no exponents here. So that tells me I'm dealing with the simplified version of an explicit rule for an arithmetic sequence. That's that extra train of thought that needs to take place for this. Now, typically when you have an arithmetic sequence that's not simplified, you just look in the front to find a sub 1. So do we just look right here at the 5 to get a sub 1? No, we can't do that because changes were made, right? This is not in the same exact format as that. So we need to be sure. And fortunately, we have our explicit rule already simplified. So we can plug in 1 to find a sub 1, right? So we plug in 1 here and here. We work it out and find out a sub 1 is actually 4. And that's what we need for our recursive rule, right? We need to say when a sub 1 equals 4. Now remember, all of this stays the same. The only other value we need to find is D. And how do we find it? Well, that's the common difference, right? How much you're adding or subtracting when you go from one number in the list to the next. Now, we only know the first value in the list at this point, so it'd be helpful if we found the second. And again, our explicit rule is very helpful. We plug in 2 to find a sub 2, giving us 9. So the first value is 4, second value is 9. So you can clearly see we'll be adding 5 every time. You could find more terms, but that won't be necessary. We found a sub 1 and D, and our answer is there. It's also right here. Number 3. For this new streamer, his subscribers have been increasing. In January, he had 154, 218 in February, and 282 in March. He must be doing something right. This pattern continued for the remainder of the year. What is the explicit rule that can be used to find the number of subscribers in the nth month of the year? This long, wordy question is basically just asking you to write the explicit rule. Because remember, n is the variable, so we can plug in 2 or 5 or 7 or whatever you want to find out how many subscribers he has at that particular month of the year. Okay, so let's take the values they gave us to write out our sequence. All they give us was the first 3 numbers, and that's all we really need. We need to find the explicit rule. So I'll let you take it from here to see if you can find the answer on your own. The next thing to do after creating that list was to determine if it's arithmetic or geometric. Now, you can look at these numbers and you can imagine if 154 is being multiplied times, let's say 2, that would already be more than 218, right? So you could also use the common ratio formula, but in this case, we want to use the common difference formula, which is take any value in the sequence other than the first value and subtract it from the value before it. And then you will find the common difference. If you did that again with 282 minus 218, you would also find 64, common difference. Great, so we found D, and we need to come up with the explicit rule. So we write it out there, we plug in our value of D, we need a sub 1, there it is, first value in the sequence, there's a sub 1. This is repetitive at this point because we distribute, combine like terms, and we're done. You will notice a lot of repetition in this unit and in this practice test, which is great for math, right? Practice doing things the same way makes you understand it better. Number 4, what is the explicit rule for the sequence? Again, they do not tell us what, whether it's arithmetic or geometric, right? So that's the first order of business. Look at the values you have and think about and work out what you know to determine that. So again, notice these numbers are very close, right? 24.5, 21, 17.5. we're probably not multiplying, right? No, we're not. And how do we find the common difference? Once again, by taking any value and subtracting it from the value before it. And notice you will get a negative difference. Very important. You always remember if the numbers are going down as you go from left to right, the difference will be negative. Okay, there's D and A sub 1. First value there, not hard to find. Once again, distribute, combine, and done. Number 5. Mr. Smith's salary is $65,000 and increases by 3% each year. What is an explicit rule for this sequence in simplified form? The one clue I will give you here is percent. Think about what it would mean to increase by a percent. Would that be add, subtract, or multiply? That will help you determine if it's arithmetic or geometric. Let's see, was it A, B, C, or D? Answer was C. Anytime you see percent, that's a multiplier. So if we see increase by 3%, that means we're multiplying, which means it's a geometric sequence. So we use our explicit rule for a geometric sequence because that's what they asked for. So what do we need? A sub 1? Well, they told us his salary right now, that's the first value we're given. It's A sub 1, 65,000. Which most of you will get that correct, but R here is where a lot of mistakes happen. You see 3%, and the most common mistake is, do you know what it is? People just go, oh, I know 3% as a decimal. I moved 2 decimal places, so it's 0.03, right? That's R. Wait a second, think about that realistically. If you were making 65,000 a year, would you want to multiply that times 0.03 and that be your new salary? I don't think so. You would be experiencing a dramatic pay cut to the point where you would quit your job. So he's getting a raise, right? So what he's ultimately doing is he's making 100% of what he made before, the 65,000, plus an additional 3%. So R is actually 103% as a decimal, 1.03. Be very careful when you're finding R. And the rest is just putting everything in its proper place. A sub 1, R, then we have n minus 1 in the power. And our last problem today, the explicit rule for a sequence is this. What is the recursive rule? So once again, we're converting from explicit to recursive. Look at your rules to help you. They really guide you with this. Notice there is n minus 1 in the place of the exponent. That should be a clue. So if you see n minus 1 in the exponent, that is the explicit rule for a geometric sequence we saw before. So we use it, right? We write it out. And we plug in what we need to know, which is A sub 1. What's A sub 1? Well, if you look at your explicit rule, it's the first value right there. There's A sub 1. Okay. So we're going to write where A sub 1 equals 625. Remember this and this is always there. Everything I just highlighted in blue is always there. We just have the values of R and a sub 1 that change. So a sub 1 we already talked about, but what about r? That 1/5? That is the rate, and if you look at your explicit rule, r is right here. So what's right there? What's right below next to the power n minus 1? 1/5. That is r. So that is your recursive rule. And that's also it for today. Come back to get problems 7 through 12.